sums and products of zeros. Consider the quadratic polynomial p of x equals ax squared plus bx plus c, where a does not equal 0, which has two zeros, alpha and beta. So in other words, p of alpha is equal to 0 and p of beta is equal to 0. Now alpha and beta are solutions to the quadratic equation ax squared plus bx plus c equals 0. Now, making the left-hand side monic does not change the solution. So by dividing each of the four terms by the leading coefficient, we have x squared plus b on a times x plus c on a equals 0, with alpha and beta as solutions. Now, since alpha and beta are roots or zeros of this quadratic, we can express it in terms of the factors x minus alpha times x minus beta. So in other words, x squared plus b on a times x plus c on a is identical to the product x minus alpha times x minus beta. Now, expanding the right-hand side, we have x squared plus b on a times x plus c on a is identical to x squared minus beta x minus alpha x plus alpha beta. And then we have x squared plus b on a times x plus c on a is identical to x squared minus alpha plus beta in brackets times x, so factorizing out the x. So that's how we get this middle term here, plus alpha beta. And you might recognize this from solving quadratic equations or even factorizing when you find two terms that add up to the middle term, but whose product is the constant term. Now, equating coefficients. So this b on a times x, okay, is equated with negative alpha plus beta times x. So b on a is equal to negative alpha plus beta. So therefore, alpha plus beta, so these are the sum of the zeros or the sum of the roots, is equal to negative b on a. So sum of zeros is equal to negative b on a, if we were sort of to write that in English. And alpha beta, so this term here, the constant term, is equated with c on a. So alpha beta is equal to c on a. So the product of the zeros is equal to c over a. Now the terms zeros and roots may be used interchangeably, as the zeros are the solution to the polynomial equation p of x equals 0. So if you recall with zeros and roots, for the most part, we can use them interchangeably because they refer to the same thing. And because we're dealing with the equation ax squared plus bx plus c equals 0 and no other number, or a number that's not equal to 0, we can use the terms zeros and roots. And sometimes I might use those two words interchangeably throughout my videos.